to formatted output, I'm actually going to need an output format for the output formatter runnable that I defined above. Remember that was already made for us. It expects a dictionary and returns the formatted output. So just to be explicit in my plan here, I'm going to include the output formatter here after the parallel execution. And then as a final detail, because I have statements, right, but I don't have my statements formatted into the dictionaries that I need for my prompt templates. I'm also likely going to need to prep my statements for use in the prompt templates. So it's likely that I'm going to need another runnable right here after statements and before I send the actual dictionaries into the parallel chain. Okay, so I'm feeling pretty happy about this. And given kind of my articulation of this, it looks like I have a clear set of steps to move forward. One, I need to create a custom runnable to convert my string inputs to dictionaries with a text field, right? This runnable here. I need to create one chain each for sentiment analysis, main topic generation, and follow-up question generation. Next, I need to create a parallel chain that includes these 3 subchains that I created, and also contain one more runnable just to extract the statement out and make it part of this whole dictionary. 4, I need to chain together the prep for inputs runnable, the parallel chain, and the output formatter runnable. And then at that point in time, I ought to be able to use the full chain to batch process my statements. Okay, so this seems like a pretty good plan to me. Maybe you have your own plan. Again, now's a good moment to kind of maybe pause, see if there's anything you missed. If not, please continue, but kind of get yourself ready to approach actually implementing this task. Okay, so if you're up for it, right, this is kind of a larger challenge for those of you who feel excited about it. Jump right in and see if you can pull this off, right? You can do your work here. As we mentioned before, don't be shy about creating additional code cells and do all the work that you want. If you want a little more scaffolding and are kind of willing to follow the approach of the plan that we just articulated, then go ahead and click on this walkthrough right here. This will kind of open up a step-by-step process of implementing this functionality where there's going to be subtasks that you can still have a chance to do on your own before looking at the solution. Kind of your pick, either jump right in or go through the walkthrough. Whatever the case may be, work on this project to your desire. And when you're ready, come back, unpause the video, and I'll go through the walkthrough, including its solutions, together with you. Okay, good luck. Have fun. Okay, so that was a pretty significant project. I hope you were successful. Let's take a look at how we approached and implemented this ourselves. I'm going to expand the walkthrough. And in this walkthrough, we're basically going to follow the course of action articulated in the solution plan above. Again, these 5 steps, you can read these yourself if you need to. I'm not going to read them all right now. The first step is to prepare inputs for the prompt templates. So we need to create a custom runnable to convert our string input into dictionaries with a text field so that they can be properly passed to the prompt template. So in order to do that, we created a runnable lambda that expects a given piece of text and returns a dictionary that has a text key and provides the input text as its property. Okay, next we need to create one chain each for sentiment analysis, main topic extraction, and follow-up question generation. Each chain should use the appropriate prompt template, as well as our LLM instance and an output parser. We defined each of these prompt templates above, so all we have to do is create the chains using the appropriate topics, and we're going to define them each with helpful names here. Okay, we claimed above that we should be able to create a parallel chain for each of these 3 tasks, because if we think about it, they don't need to occur serially. And then there's a 4th part of our parallel chain where we just want to get the single statement itself. So here we're going to, and what that's going to result in is the parallel chain returning a dictionary that has the 4 values that our final output parser is expecting. So the way that we did that was to use runnable parallel, where for the sentiment property, we included the sentiment chain, same for main topic generation, and same for follow-up. And then to get a statement property, we just defined a very simple runnable lambda, where for the incoming dictionary, we simply retrieved the value of the text field. And this means that we now at statement have just the string of the statement itself. Okay, so now we need to chain together the prep for inputs runnable that we made earlier, the parallel chain we just defined, as well as an output formatter runnable that we did above. So here we create our chain and do just that, prep for template, and then the parallel chain, and then the output formatter. Just for fun, I guess, we'll look at the graph output for this. And you can see we get our input. It goes through our initial runnable lambda. It then hits a parallel chain that has 4 properties, sentiment, main topic, follow-up, and statement. For the 3 LLM-related tasks, we take the chat prompt template, the LLM instance, and the output parser. For our simple task of simply getting the statement out of there, you can see that's a more simple edge of this computational graph. This parallel chain completes, and we end up with an output to our parallel chain that has, again, the sentiment, main topic, follow-up, and statement properties. We then send this through our final runnable lambda, which again is our kind of output formatter, and get our final output. The last thing we need to do now is to actually execute the chain. So we have our chain. We're going to batch it with our initial statements. That gives us our formatted outputs, and if we were to loop through all of them and print each one of them, you see we get exactly what we wanted. Okay, so you are really starting to get your hands dirty with being able not only to use large language models for a variety of tasks using LangChain, but much more importantly, how to compose tasks together. Multiple language related tasks, custom functionality as a part of your tasks, parallel execution as a part of your larger tasks. All of these are core techniques that are going to assist you in your ability to tackle all sorts of application use cases using large language models. So you're going to be continuing to compose runnables into chains for the duration of the workshop. But starting in the next section, because again, this concludes section 2, so we'll be moving into section 3. Starting in the next section, you're going to dive into LangChain messages. This is something that has actually been getting utilized under the hood, but we haven't been using explicitly in our code. But in section 3, we're going to look at how to leverage messages explicitly for a variety of really helpful and powerful techniques for getting large language models to behave in the way that we would like to, and including the ability to understand how chatbot functionality that retains conversation history is possible